everyone. Here is the last podcast for Chapter 8, and we're leading into talking about how do you solve story problems, which are applications of sine, cosine, and tangent. So just as a quick warm-up, see if you can match these. So see if you can kind of look at that and be able to figure out which one goes with which. And then you could just pause it. The sides that match, the longest side of the triangle, of course, is going to be the hypotenuse. Adjacent, opposite over adjacent is our buddy tangent. The one that is diagonal from the reference angle, that is going to be opposite. Adjacent over hypotenuse, that would be cosine. Next to the reference angle, but not the hypotenuse, would be adjacent. And the opposite over hypotenuse would be our function of sine. How'd you do? So today's topic is talking about angle of elevation and angle of depression. And I have one like this where we can try to manipulate this a little bit. And so what's going to happen here is if I try to kind of get this perfect and line it up a little bit. If we were in the top of the lighthouse looking down, that would be a different approach. But let's say we're in the boat and we want to be able to, from our line of sight, we can see the lighthouse. And so therefore this would make a right triangle. And this would be called an angle of elevation. So the angle of elevation would be this angle right here. That's formed with the line of sight and to the top of the lighthouse. So if they say angle of elevation, we're going to put that at the bottom. If we're saying, what if we're at the top? So let's say we're at the top of the lighthouse and we want to look at from the boat. So the line of sight is still going to be up here, okay? And then if we're going to spot the boat, it's going to make a different triangle. This is called the angle of depression. Okay, notice it's in a different triangle though, so you can't assume from the other, triangle. So depression looks a little bit different than elevation. However, if we put the two together, notice how it's going to make this lovely Z shape. And we talked about angles like that. And so we know from past experience that therefore we have angles that are equal. Hopefully you remember these. These are alternate interior angles. And so the angle of elevation and the angle of depression are the same. So again, the angle of elevation is going to be equal to the angle of depression. So I don't care if they give you an angle of elevation or an angle of depression. You know where you're going to put it? You're going to put it right there in the bottom part of the right triangle. Okay, whether your triangle is facing like this or if it's going to face the other direction. So always put that lovely angle of elevation, depression, that acute angle, put that down here. Okay. And if you want, draw a quick sample of an angle of elevation and angle of depression, because I have that in your notes. And you can go back to the other two pages and draw a little bit better picture that would go along with that. And you could draw the lighthouse if you'd like to do that. Another way to also think about it is to go to, this is the page I wanted. So here's an angle of elevation and an angle of depression. And if you take a look at it, it really demonstrates and shows how if, again, you have that, particular side put in and how the angle of elevation and the angle of depression, see how they're both marked equivalent, so they are equal to each other. So again, that's a very important relationship. So let's solve some problems using sine, cosine, tangent, using these angles of elevation and angles of depression. It's taking longer than I want on this. And I apologize for that. It doesn't want to quite do it. So, as I mentioned earlier, the angle of elevation and the angle of depression are equivalent. And so we're going to utilize that by solving a problem. So we have a monkey, he's hanging from a tree, he spots a banana. And so we're going to measure the angle of elevation and depression. So if you look at here and you look kind of at the monkey, Okay, and so I've kind of got it lined up perfect, and it's kind of hard to see, but if I hit this little equal sign, and let's say I want to pull this, do you see how it's 23 degrees? So this angle is 23 degrees. I don't know if we necessarily want that, but it's 23 degrees. If I go up here and I measure it and I turn this, so obviously I can measure stuff again and get it right nice on the monkey, you're going to read this dial, and again, you're going to get 23 degrees. So this is backing me up about talking about the angle of depression and the angle of elevation and how they're equivalent. Okay, so we're going to go to the next page, which is going to help us with that. And I started kind of working on it already, so I'm going to quick clean it off so you won't need to see all that. So we have a monkey hanging in the tree, 68 feet tall, spots a banana at a 23-degree angle of depression. What is the direct distance from the monkey to the banana? So what you're basically doing is this. You are working on being able to find that direct distance. So we're going to draw a picture in. Okay, and so what that means is you're going to make a triangle connecting from the tree to the banana, and then from the banana to where the monkey is. And of course, you can imagine this as your, there you go. And then there's my altitude, and there's my right triangle. So we're going to put in our 23-degree angle. Now remember, that's a depression. Really, the depression angle is up here. But remember, depression is the same as elevation. So the 23 would, what we really want to do is put it in the triangle. So it's there. And we know the tree is 68 feet tall, so we're going to put a 68 there. Now we want to know the direct distance from the monkey to the banana. So that's here. So now we have to think, okay, what is 68 to the 23? Is it opposite, adjacent, or hypotenuse? Well, the 68 is opposite. And the x, that'd be the hypotenuse. So we would use our buddy sine. So sine of 23 degrees is equal to opposite 68 over the hypotenuse, which is x. And you're going to do a switcheroo. Remember we talked about when the letter's on the bottom, we're going to take 68 and we're going to actually divide it by the sine of 23 degrees. And so once you do that, then you're going to grab your calculator. And so we're going to type that in. And so just as to remind myself, we've got 68 here. So I'm going to do 68. And I'm going to divide that, hit my trig button. And then I've got sine. And then we're going to type in our angle, which was 23 degrees. And make sure, again, your calculators are in degree mode. And so there would be our distance. So it's pretty much 174 feet. And that would give us our answer. So how far is the monkey away from the banana? 174 feet. Answer done to the problem. Okay, here's another problem. So let's say we have an angle of depression from the top of a lighthouse to a fishing boat, and we have the distance from the top of the lighthouse to the fishing boat is calculated as 150 meters. How far is the fishing boat from the base of the lighthouse? So what we would do again is make sure that we draw some kind of triangle. And so we would have the boat here. There's your lighthouse. Technically, I should probably make the boat smaller, but oh well. It's a thought that counts. And so we have that particular triangle put in. We have the angle of depression. Remember, again, that means it's going to be up here. But remember, the angle of elevation is the same as the angle of depression. So therefore, it's 18 down in our triangle. We know the distance from the top of the lighthouse to the fishing boat is 150 meters. And we're trying to figure out how far is the fishing boat from the base of the lighthouse. So that would be the bottom. So that's the part you can call X. And so maybe kind of figure out which one's opposite, which one's adjacent, which one's the hypotenuse. And so therefore, from the 18 degrees, the X would be adjacent because it's next to it, because the opposite side would be right here. And then by the process of elimination, the 150 is the hypotenuse. So hopefully you figure out what function we need to use. We need to use cosine because we have adjacent and we have the hypotenuse. So we could say cosine of 18 degrees is equal to x adjacent over the hypotenuse, which is 150. Now notice here the letter's on top, and hopefully you remember how to solve that. That means we just multiply both sides by 150. And now it's all calculator work. So then we would just type that in with the handy dandy calculator. We take 150, and then we had our function of cosine, and then type in our 18 degrees, and then hit enter. And so how far is the boat from the lighthouse? About 142.7. So that would be our answer. So 142.7 label meters. And we're just going to work on some story problems. So just using sine, cosine, and tangent. So solving it should be a piece of cake. And if you have any questions, just ask in class. See you then.